Is it lighter?
Is it working? Okay. All right. Quadratic functions. Holy cow. Quadratic functions are pretty loaded stuff. All right. What does a quadratic function look like when you graph it? He looks like a parabola. He looks like any one of these three shapes right here, right? Any one of those three. If you can't see him very well, you can make him darker, right? This guy, or this guy, or this guy, right? Okay? So any one of those are quadratic functions, okay? And you wouldn't think that that has a lot of information, but there's quite a few elements to quadratic functions and things that we know. We've already done some stuff with quadratic functions, like finding the, or using the quadratic formula, negative b plus and minus b squared minus 4ac all over 2a. Okay, now, you guys had a question on your test which asked you, what does that thing do for me?
It finds the exact solution.
Yeah. I don't know, you got it wrong. Well, here's this. If you have the graph of the function and you have a parabola that looks like this, these two places are what it is finding, right? Now, sometimes you may not have two places. Sometimes you may have only one place, right? That looks like this. Maybe he's touching just at one point right here. Or maybe you have the graph that looks like this, where he is not touching at all, right? Okay? And do you remember what happens with your quadratic formula when each one of those things take place?
There's two solutions, one solution.
Two solutions, one solution, no solutions. This is two solutions, one solution, no solutions. But how do I know using the quadratic formula that that is happening to each one of those? Yes, this would be like a positive number inside of the square root, right? One solution would be taking the square root of 0. And then no solution would be taking the square root of a negative. So it all boils down to this b squared minus 4ac, what he looks like. Yeah, is this all kind of coming back to you?
Sure.
Two solutions if it's positive. Why 2? Where do the two solutions come from? Plus and minus in front, right? Those are the two solutions. If it's 0, if you're adding 0 and subtracting 0, it's the same number, right? So it's only one solution. And then negative, you can't take the square root of a negative number, so that is when you have a parabola that is not touching the x-axis. It's either going up, or you might have something that looks like this where it's going down as well, right? Okay, he could be on the bottom as well, right? Or something like that. So quadratic functions are pretty loaded. There's a lot of information that we can tell about quadratic functions. And quadratics are used a lot in science because they have to do with like projectiles, right? What's a projectile?
This. Flying thing.
This, and he throws a marker.
Throw it and then that go up and then
Right, right.
Controlled once it has been released.
Yes, sure. That's a good thing. So it is something that's thrown or launched into the air or something like this. I always use this analogy. If I am going to projectile, if I am going to projectile vomit onto Colton, if I am going to projectile vomit onto Colton,
Literally just say throw up, but you have to say projectile vomit.
Projectile vomit. Well, I could throw up, but I could throw up like this just into my hands, right? That's not going to be a quadratic function. But a quadratic function, if I am launching my puke into the air.
Projectile vomiting is exactly going straight down.
Well,
Your terminology.
but I am projectile vomiting like out, so that it does hit Colton.
Oh my gosh,
That's what I want. That's what I want to happen.
It's in pitch perfect.
Yes, exactly. And it like turns all the way out, right?
Oh man, I've got them all distracted.
I know. So, all of these things, like when you projectile vomit, things like that, those all are parabolic functions, right? Okay, kind of disgusting. All right, let's go on now.
Why do we always choose the nasty topics?
I don't know. Okay.
Projectile crap.
Oh, yeah. Okay. So I'm gonna change. Listen.
That's nasty.
Listen. All right. I'm gonna change some of these instructions here. Okay. They have 3 different forms that a quadratic function can take. Okay. 3 different forms, and all of these are quadratic functions, but they just look a little bit different. Okay. They call the first one transformation form. I'm going to call it vertex form. I'm going to call it vertex form, okay? And vertex form, I'll give you an example of this. This would be like y equals I'm going to say 2 parentheses x minus 3 squared plus 4. Let's do that. Okay? Now, the reason why this is vertex form is, if you guys remember your transformation from algebra 2, right? This guy is moved 3 units to the left. No, right. 3 units to the right, because minus means right, actually, when it's in parentheses. 3 units to the right and 4 units up. 4 up. Okay? So my vertex is 3, 4, right? That's why vertex form is really nice when you're trying to find the vertex, because it's just 3, 4. It's just whatever these guys are. What does the 2 do to it?
Doubles it.
What? No, it's not minus 4. You only change the sign of the one in parentheses. Good question. It makes him taller, but making him taller is not going to change the vertex.
No.
Did I really? No, I did not. What?
Yeah, you.
Oh
Oh,
my
it's
gosh. Oh
this
my
one's
gosh.
plus 4.
What a
It's
deal. That's so good.
No.
Anyway, so there's that. All right, now the next one is called polynomial form. I'm going to change it, and I refer to this as standard form. Your book will call it polynomial form, but I like to write it in standard form. Standard form is the form that you think of when you think of a polynomial function, or a quadratic function. So this would be like y equals x squared plus 4x plus 3. I don't know. That is standard form. He's written x squared, x numbered, no parentheses, nothing like that. Okay? And then x-intercept form. You won't see this one very often. I do call this x-intercept form. So I leave that one the same. But he is written as, I'll give you an example. Y equals x plus 3 times x minus 2. Okay? You don't usually have quadratic functions start out in this form. You're trying to get it to this form. But the thing that's really nice about this guy is I can find where he crosses really easily, right? By setting it equal to 0. So he's going to cross at -3 and +2, right? Because you set this equal to 0. So x-intercept form is really nice because I can find it really easily, right? The other ones, vertex form, polynomial forms, each one of those have a reason or a nice part of it. X-intercept form is good for finding the x-intercepts. Okay, let's go down. Here, the vertex and vertex form, or transformation form, vertex form. If this is our function, what's the vertex? Hold on, not -3. If that's our function, what's the vertex? +3, -4, right? You take the opposite sign of this guy right here, opposite sign. And this guy is the same sign. Okay, opposite sign, same sign. And then they want us to find the x and y intercepts, okay? So, we know that his vertex is at 3, -4. I'm going to go down here, 3, -4. I'm going to put my dot. There's my vertex, okay? And then the next thing I'm going to do is find the x and y intercepts. So, if I do the x-intercept, let's do this first. X-intercept, that one's harder. Here is my function. Y equals 2 times x minus 3 squared minus 4. If you're finding the x-intercept, you plug 0 in for y. You plug 0 in for the opposite one. X minus 3 squared minus 4. Okay? All right, so I plug 0 in for y. If I'm trying to find the x-intercept, I plug 0 in for y. So now we've got to move this around. We've got to solve for x. Okay? Yeah. This one's not too bad, though. Some of the other ones are awful. How do I solve for x here? No, we don't want to foil. We don't want to ever foil. Add the 4. Let's add the 4. We got to get the number by itself. Add the 4. So 4 equals 2 times x minus 3 squared. Divide by 2, exactly. So 2 equals x minus 3 squared. And then somebody already said it, take the square root. Okay? Take the square root. So we have the square root of 2. And then we've got x minus 3 on this side. Square root of 2, so add the 3 over. So 3 plus the square root of 2 equals x. I promise the other one won't be quite so much work. And nobody's catching my mistake. Plus or minus.
Wait.
We took the square root, right? Plus and minus. So make sure you put your plus and minus in there. Okay, now,
Chill.
those are going to be my 2 places where he crosses. Okay, let's figure those out as decimals because I want to be able to graph this thing, right? What is 3 plus the square root of 2 and 3 minus the square root of 2? Somebody do that real quick. Somebody do 3 plus and somebody do 3 minus.
We're doing
Decimals, yeah. Just so I know where that's at, right? What's 3 plus the square root of 2 and 3 minus the square root of 2?
minus 3. Yeah, isn't it minus? You wrote plus 3.
What? 1 point what?
1.6.
4.6?
1.6 and 4.4.
1.6 and 4.4. Okay, so those are where he's going to cross the x-axis. 1.6 and 4.4. 4.4, 1.6. Something like that, right? Do you see where my parabola is located? Okay, he's going to do that. All right, now the last thing is the y-intercept. Okay, I promise this won't be quite so much work. The y-intercept. How do you find the y-intercept? Put 0 in for x this time. So y equals 2 times 0 minus 3 squared minus 4. Okay, so let's do this. 0 minus 3 is negative 3. Negative 3 squared is 9. 9 times 2 is 18 minus 4 is 14. So he's going to cross all the way up here at like 14, which is double. It's like off the graph, right? If I go down, he's going to cross all the way up here. If this is 7, then that's 14. He's going to be a really skinny guy. Like that. Okay? That's what he looks like. Okay?
What do you have inside the way? Wait.
What?
0 minus
0 minus 3. You plug 0 in for x. Yep.
0 minus 3.
Is negative 3, and negative 3 squared is positive 9. And 2 times 9 is 18, and 18 minus 4 is 14. He's crossing at 14. You see how that all works? Yeah?
Wait,
So we found all 3 of those pieces. X-intercept, y-intercept, and vertex. All 3 of those things help me graph my function.
Oh, so where's your 14 going? On both sides? Up?
Kind of. Yeah, I just put it there just so that you can see. Really, Erica, it's going to cross at 14 over here also. So in the same spot, it will be like the same distance away. Yeah. Okay. All right, good? Yes? Beautiful? Okay.
Could I say this?
Now, we'll do one more thing. One more thing. Now, this is going to take a while, I promise you. It's kind of a long process, okay? So, one more thing. Polynomial form is the next form. I call this standard form. Okay, I call this standard form. Instead of polynomial form, your book might call it polynomial form. That's fine. Standard form. Okay, now, vertex form is really nice to find the vertex because you just look at what's in the parentheses and on the end, right? Those 2 numbers, that's your vertex. But standard form is a little bit different. It's ax squared plus bx plus c. You've seen that before. My example of standard form up here was x squared plus 4x plus 3, right? Okay, something like that. How do you find the vertex when you are in standard form?
You don't. You give up on it.
You give up on it, right? Okay. There's a formula.
Right there.
It's right here. Okay, you need to remember this. Negative b over 2a. Negative b over 2a. Negative b over 2a. Right? That's how you're going to find the vertex when it's in standard form. Okay, now, listen. Shh. Negative b over 2a. It's not a coincidence or not just random. It's not random that negative b over 2a shows up here, right? That is not a coincidence. That is significant. That's important. Okay? So negative b over 2a is how I find my vertex. Okay, so if my function here is x squared plus 2x plus 3, and we do negative b over 2a, what is b?
Negative 2.
Yep, so we put negative 2 over 2 times a is 1. What is that? Oh, that's really nice. Negative 1. Okay, that is my x coordinate. Now, how do I find this y? How do I find the y coordinate of the vertex?
You plug that in there.
You plug that in for x. So it has f of negative b over 2a in the formula, but I just cross this out and I say plug x in. Plug x in to find the y, right? So all you need to remember is negative b over 2a, and then you plug that in to find the y, right? Okay. So let's plug negative 1 in and we'll find y. So negative 1.
Squared.
Negative 1 squared. Now make sure you plug them in parentheses, otherwise this is going to screw things up. Okay. Negative 1 squared plus 2 times negative 1 plus 3. Negative 1 squared is positive 1. 2 times negative 1 is negative 2 plus 3. So what's 1 minus 2 plus 3? What? 2? 2? Okay. So negative 1 comma 2. This is my vertex. Okay, now let's talk about something else that we haven't done yet, right? Is this going to be a smiley face or a frowny face?
Smiley.
Brown.
No, just smiley face because
The first
X,
X.
the X
Yes.
squared.
So that's another thing. That's another important thing right here.
God dang it, Cody.
If this guy is positive or negative,
That's good. I don't like
positive or negative, it's going to smile or frown based upon that. So positive, negative, smile or frown. This guy is going to smile, right?
Wait.
Okay. This guy is going to smile. So here's the deal. He's going to look like, well, let's just wait. If we're finding, they want us to also find the x-intercepts, and they want us to find the y-intercepts, right? So, x squared plus 2x plus 3, I'm going to set equal to 0. I'm going to plug 0 in for y, right? 0 goes in for the y coordinates.
Positive and smiling.
If A is positive, it's smiling. If A is negative, it's frowning. Yes, yes. Okay, so I'm trying to find my x-intercepts, okay? And, like, what you're going to want to do is to factor this thing down, right? If you can, right? So can you multiply to get 3 but add to get 2?
But why don't you just go minus 3 divided by 2? Positive minus
Because you can't do that, Cody. Like,
Where's
teach.
there?
Divide.
Maybe you'll learn how to do it. What are you talking about?
Divide the 2 out.
No, not gonna work. You can't do that. So if you can't divide the 2 by this guy. Right? I gotta do your 2. Okay? So going back to factoring. Listen. As soon as we get done with this, we're done. So going back to factoring, can you multiply to get 3 but add to get 2? No. Okay, so let's try this. Listen for just a second. Let's try quadratic. Okay? Just try. Negative b would be negative 2 plus and minus square root. B squared. What's b squared? 4 minus 4 times 1 times 3. All over 2 times 1. Okay? Now let's look at the inside here. 4 times 1 times 3 is 12. What's 4 minus 12? Negative 8. Uh-oh. What's happening? You can't have negative inside the square root. So what does that mean? There are no x-intercepts. None. We should have already known that because my vertex is here and he's smiling, right? He can't be here and smiling and touch down here, right? There's no way that not be a quadratic. He could go down the other direction and be like a portrait function.
That would be a frowny face.
That would not work, right?
Mhm.
Okay, so
It's the X
he
squared.
cannot touch down here. He cannot touch down here if he's smiling from this point, right? It doesn't work.
But if he was negative, or like a frowny
If he was
face,
negative, then we would have it work. Yes, correct. Okay, now the next one, the last one. Find the y-intercept. I'm going to plug 0 in for x, so this one's easier. Y equals. Y-intercepts are always easier. 0 squared plus 2 times 0 plus 3. Okay, now you should be able to do this in your head and not have to think about it too hard because these two pieces are going to knock out, right? Anything times 0 goes away. So what is y? 3. He's going to touch at 3. So I'm going up here to 3 and he's going to touch there. But then also, I like to do this. He's over here at negative 1, comma 2, and he's touching up here at 3. So he is 1 away and 1 above. So I'm going to go the other side and I'm going to do 1 away and 1 above just to make him uniform on the other side. Does that make sense?
Yeah.
Because I know he's going to be the same on both sides and that's what my parabola is going to look like. So he's going to go like this.
Skinny.
Something like that. That's where he's touching. Yeah?
Yeah.
Okay? Something of that nature. That's what he's going to look like. Yeah?
Yeah.
That gives you a good idea? All right?
Erica is.
So, we'll stop there. Okay? If you want to start the homework, it would be a really good idea.
You.
Because it's going to be a while. Okay?
I got physics.
Oh, it's your go, Rush.